Hello everybody. In this lesson, I will do some practice examples on tree diagrams in probability. Example 3. In a factory, 3 machines M1, M2 and M3 manufacture sets of bolts and nuts. They produce 25%, 30% and 45% of the total production respectively. 18%, 5% and 2% of the goods produced by machines M1, M2 and M3 respectively are defective. A set is selected at random from the total production. Number 1. Represent the information by means of a tree diagram. So if you look at the tree diagram here, you can see we've got 3 machines. Machine 1, machine 2, machine 3. And then machine 1, there's defective, not defective. Defective, not defective. Defective, not defective. Now let's fill in the values. So the first one is machine 1 produces 25% and 25% is the same as 0,25. Machine 2, 30%, 0,3 and machine 3, 45%, which is 0,45. I said 45 divided by 100 is 0,45. Then the next set of information is 18%, 5% and 2% that's defective. So we find defective there for machine 1, 0,18. Defective for machine 2, 0,05. Defective for machine 3, 0,02. Now, we have to calculate the not defective part. And now it's the principle, remember probability always add up to 1. So what you actually say is 1 minus 0,18 is 0,82. And if you just check that, 0,82 plus 0,18 is 1. And then on the next one, it's 0,05. So we say 1 minus 0,05 and we get 0,95. And then for machine 3, we say 1 minus 0,02 is 0,98. And then there we have all the numbers we need for the branches of our tree diagram. Now, what happened here, let me just show you this one. This is now, if you go across with your branches, it's the outcome is M1 defective. And then it's 0,25 times 0,18. This next one, the second one, is machine 1 not defective, will be 0,25 times 0,82. Number 2, calculate to 3 decimal digits the probability that a defective set of bolts and nuts was manufactured by machine 1. So we go to machine 1 defective. So it's this one. It's machine 1 defective. So what we do is we say probability M1 and defective is 0,25 times 0,18 is 0,045. Number 3, calculate the probability that the set is defective. So where is that now? That is now everywhere from all 3 machines where you find a defective set. So this one has a defective set, that one has a defective set, and that one has a defective set. So it's those 3 that we're going to add together. So what did I do there? You can see everyone that has a defective. It's 0,25 times 0,18 plus this one, 0,3 times 0,05 plus this one, 0,45 times 0,02. And then when you work all of that out, you get 0,069. And as a percentage, it's You times it by 100, so there's 6.9% probability. Example 4. A bag contains 3 red and 2 white balls. A second bag contains 5 red and 4 white balls. A bag is chosen at random and a ball is taken from it. 4.1. Draw a tree diagram to show all the possible outcomes. So what I've got here is the 1 represents the one bag and 2 the other bag. And then the R and the W is a red from the first bag and a white from this first bag, and a red from the second bag and a white from the second bag. So you've got half a chance of pulling out a ball from the first bag and half a chance of pulling out a ball from the second bag. Then on the red, on the bags now, let's look at that. So a bag contains 3 red and 2 white balls. In other words, there's a total of 5 balls. So therefore, in bag 1, you have a chance of 3 out of 5 picking a red ball, and then a chance of 2 out of 5 choosing a white ball. And then in bag 2, you've got 5 red and 4 white, which gives you 5 red, 4 white gives you a total of 9. So therefore in bag 2 you've got a 5 out of 9 chance of pulling a red ball and a 4 out of 9 chance of pulling out a white ball. And then your outcomes will be from bag 1, a red ball is a half times 3 out of 5. Bag 1, a white ball is a half times 2 out of 5. Bag 2, a red ball is a half times 5 out of 9. And bag 2, a white ball is a half times 4 out of 9. 4.2. Using your diagram, determine the possibility of the chosen ball being red. So it's this one, that outcome, because it's a red ball from bag 1 and a red ball from bag 2. So you're going to add those two. So the probability of choosing a red ball is 3 out of 10 plus 15 out of 18, which is 0.58. In the next lesson, I will introduce two-way contingency tables in probability. Click on the video in the left-hand corner to take you straight to the next lesson.